All right, guys, so this first section of chapter 5 is all polynomials, right? So we're going to have some x squared, we're going to have x cubed, x to the fourth, x to the fifth, and we're going to learn all kinds of things about them, looking at their graphs, looking at how many answers they have, how to find all of those answers. So first thing about these, they're all polynomials, what they're all called. Polynomial comes from poly, which means many. Nomial means terms. That means it has many terms. Bless you. And then terms are all of the like chunks, right? The pieces that are separated by a plus or minus. So this one has 3 terms. Somebody know what you call something that has 3 terms? Yeah, trinomial. Right. Kylie, now is not the time to do your homework. All right, so first thing is the degree. Degree is our first vocab term. You know what that means. So degree of a polynomial in one variable, everything we're doing has one variable, just an x, right? Because you could do x and y, x, y, z. We're just looking at one variables. It is the highest degree of its terms. So the degree is the highest exponent. So looking here, right, like that one's got a 2 on it. That's like x to the first. So the highest exponent is 3. That has a degree of 3, a third degree polynomial. Right. For me, it's easy to remember degree. Like if I would tell you it's 32 degrees outside, right, it'd be 32 degrees. Where's that degree symbol located? It's like where an exponent is. So when you think about degrees, you know, if you write degree symbol, it's up high like an exponent, so it deals with exponents. Okay, it's a nice way to remember that one. The leading coefficient, leading means it should be first, right? Coefficient is just the number in front of the variable. It's the coefficient of the term with the highest degree. So like this one right here, not written in the right order, right? It should be this one first because that's the highest, right? This is a 5th degree. That's the highest. And the leading coefficient would be whatever number's in front of that one. So it would be -8. So we always want them in the right order. We want, right, the highest exponent and then kind of stair-step them down to the lowest one. So, which brings us to standard form, which we just talked about. So you want exponents in order, highest down to lowest. We got a little vocab on here, which I'm sure you've seen these words before, right? The first one is cubic, because it's x to the third, which is cubed. So that's your cubic term. Quadratic is what we whole last chapter was x squareds. Linear term, if you graph something with just an x to the first, that makes a straight line. That's linear. And then the number all by itself is called your constant. So write the following polynomial in standard form. This is the same example from the last one. We already talked about, we know that one should be first, right? So -8x to the 5th. Which one should go next? Good. So plus 4x cubed. Then 10x. And then your 7. So you want your exponents in order, highest down to the lowest. Okay, so polynomial functions can be classified by their degrees or by the number of terms that they have, right? You told me earlier that 3 terms, like Julia said that was a trinomial. Okay, so we have to make sure we're keeping straight in our mind the difference between degree and terms. People confuse those two all the time. So degree, number of degree symbol looks like an exponent. So if I look at, like, we have just some examples to talk about here. So this one right here, just the number 5, that is a constant, right? It's just a number, there's no variable. So what degree does it have if there's no variable? It'd be 0. Degrees are the exponents on variables, and it doesn't have one, so it'd be a 0. How many terms is that? That's just one term, right? It's just one piece, right? Terms are kind of your chunks, your pieces. Do you know what you call something with one term? What? Nope. Monomial. Good. Monomial. Mono. Which always makes me laugh, you know, like the sickness, if you have mono, they always call that the kissing disease. But mono means one. Not really sure why it's called the kissing disease. All right. This example, x plus 4, this one's linear because what degree is it? What's the exponent on my, that's a 1, right? So if it's a degree of 1, it is linear. How many terms does that example have? 2. right? There's one piece, second piece. So two terms is called a binomial. Binomial. Think of a bicycle has two wheels. Binomial, bicycle. Okay, next one. All of last chapter was an x squared, which is quadratic. So it has a degree of 2. How many terms is that one? That's just the one term, 4x squared, just one piece. Right, terms are separated by plus and minus signs. So this is just one term. And one term is called a monomial. All right, the next one, 4x cubed minus 2x squared plus x. The highest exponent is a 3, which means it is a third degree, or its fancier name is called cubic. How many terms does that one have? 3. Okay, there's 1, 2, 3. And something with 3 terms? Good, trinomial. All right, the next one, the highest degree, highest exponent is 4. Its fancy name is quartic. The easiest way I always remember that one, quartic. How many quarters are in a dollar? There are 4. How many quarters are in a football game? 4. Right, how many quarts are in a gallon? 4. And you're like, 4? I don't know. Yeah, it's 4. I am too. I'm terrible at those. All right. How many terms is this one? That is 2, right? 1, 2, which is a binomial. All right, and the next one, quintic, the highest one is a 5. I don't have a great way to remember that one other than like quintuplets. That's 5 babies. It's not a great way to remember it though. I guess by default, that's the other one, right? Quintic is 5. How many terms does this one have? 1, 2, 3, 4. What do you call something with 4 terms? Now be careful, what does quad mean? Quad actually means 2. That's quadratic. It's 2. Be careful with that one. I know, I think of like my brother used to race 4-wheelers. They were quads because they're 4-wheelers. It gets very confusing. All right, but quadratic is 2. So, but that's actually not a thing. So, what's this one called? Nope. You guys are trying to get creative now. It's just a polynomial. It's like somebody got tired of making fancy names and just stopped. That's what that kind of is like. All right. Now the table's great, shows you some examples and things, but I find students sometimes get themselves a little confused. Let's kind of break this down just a little bit, okay? So just off to the side somewhere where we have a little bit of space. So you can organize and classify things by degree, or you can do them by terms. So again, degree is your highest exponent. Again, I always think of degree, 32 degrees. That little symbol is up top like an exponent. So if you have a degree of 0, it is called a constant. Constant. You will have to know these terms, okay? Every time I ask you for degree, I don't want the number 4. I want quartic. I want quadratic. I want those fancy names. You have to use them. All right, a degree of 1 is linear. A degree of 2 kills me when people miss that one. Like, man, our whole chapter 4 was quadratics. Degree of 3. Degree of 4. Degree of 5. Quintic. And then 6 or higher. Just give me the number. So like 6th degree, 7th degree, 8th degree. So you are required to know up through 5. Just the number. Yep, so 6th degree, 7th degree, 8th degree. All right, and then terms, you may want to let yourself a little note here. They are separated by plus or minus signs. All right, they're the different chunks kind of separated. One term, that's your monomial. Two terms, binomial. Three terms, good. And then 4 or more is just polynomial. Now, I need to make sure we understand, though, they are all polynomials, just like you are all students. But more specifically, you are Grace, right? You are Adam. You have specific names. So it's kind of like that. They're all polynomials, no matter if they have 1, 2, 3, 4, whatever terms. But we have specific names for 1, 2, and 3 terms. Okay? So highlight, circle, star, all of this info, you have to memorize this. You have to know it. I'm actually going to quiz you on it today, so make sure you got that. All right, so write each polynomial in standard form, classify it by degree and by the number of terms. All right, so the first one there, what order should it be written in? All right, so 9x squared plus 3x plus 5, that's just standard form. All right, classify it by degree. So this is standard form. By degree is what? Quadratic. Good, because that's a 2, so that's quadratic. And then by the number of terms, that is a trinomial. But you can see how people flip-flop degree in terms, right? I have people tell me, like, oh, it's 3 terms, so it's cubic. No, that's trinomial. Okay, just keep in mind that degree symbol is an exponent. All right, how about the next one over there? What order should that one be written in? Standard form. What? X to the 4th. Yes, I can. You got like terms? Go ahead and put those together for me. Good. Yeah, if you have like terms, guys, put those together. All right, so there's your standard form. Okay, by degree. Good, that's a 4 there, so that's quartic. And then by the number of terms, good, polynomial, because it was 4 terms. All right, how about the third problem here? 3x cubed minus x plus 5x to the 4th. Good, 5x to the 4th plus 3x cubed minus x. All right, how about the degree? Quartic again, because that first one is a 4. And then by the number of terms, trinomial. All right, let me give you a second and do that last one on your own for me. Was that already in standard form? I heard yes and I heard no. You guys realize that technically this would be problem 4, right? Not problem 3. That's a like term with that. Every year about half the students do that. They're like, oh, I thought that was problem 3. So standard form would be negative 4x to the 5th plus 2x squared plus 13. Make sure you put that 13 on the end. That's not problem 3. All right, so then by degree, quintic, good, because that's a 5. And then by the number of terms, trinomial, good. Questions on how to tell all of that stuff? Awesome. All right, so looking at the graphs, we've looked at some graphs here recently, right? We were graphing a lot of quadratics. All polynomials have some similar characteristics. They'll be continuous, right? There's not going to be gaps in spaces. There's not going to be holes in them. There's not going to be any sharp turns, no sharp points. Everything's nice and smooth and flows, okay? So we're going to start seeing some graphs that actually have more curves than the normal ones. All right, so real quick, we're going to kind of break this apart a little bit. So I want this first table. I'll grab your graphing calculators, guys. First table here, you guys are going to graph x squared. You guys are going to do negative x squared. You guys are going to do x cubed. You guys are going to do negative x cubed, Martin. You guys are going to do x to the fourth, negative x to the fourth. And you guys are going to do both x to the fifth and negative x to the fifth. You guys get 2, sorry. Oh, do I have 6 on there too? And then everybody do x to the 6th and negative x to the 6th. And then we'll kind of put it all together. So I'm going to give you just a minute. Go ahead and graph the one I asked you to, or the couple I asked you to. Just draw me a rough sketch on there. I don't need you to like find the vertex. I don't need you to plot specific points. Just give me a rough sketch of what it looks like. Okay? Rough sketch. Do you remember how to graph? Hit y equals. To change your exponent, guys, remember you just hit the little caret button. Looks like half a part of a triangle top to bottom. Nope, don't find actual points. Just draw me a rough sketch of what it looks like. That's all I want. Just a rough sketch. X to the 6th here, since both of these are pointing up, that's what its ends will always do. Now, what's happening in between there can change, but its ends will always point up. X to the negative x to the 6th, its ends will always point down, but in between there, you could see some more curves and stuff happening, okay? Its most basic one, you don't really see anything. But the more you kind of like add 4x to the 3rd plus 6x squared minus x, you know, like add extra stuff into that equation changes what's going on in between. But its ends always look the same. So that is why your next slide in there has end behavior in a nutshell. So kind of wrapping all that up, what does end behavior mean? So end behavior, we can tell what its ends are doing, whether they're pointing up, pointing down, one up, one down, whatever, just based on what its exponent is and what the coefficient is. So the even exponents, so x squared, x to the 4th, x to the 6th, what do they look like? They look like a parabola. Way to use your math terms. I was totally not going to use a math term, right? The positive ones looked like a smiley face, and the negative ones looked like they look like a sad face, right? That negative just takes my graph and flips it, right? So I like ways to remember these kind of things because you will have to know this. If it's an even exponent, I always think of like you're an even-keeled person, you know, pretty normal, pretty calm. But if you're positive, you smile a lot. And if you're negative, you're sad. Looks like a sad face. But the odd ones, Martin, how did you describe the odd ones? Wacky. I like that description. They're kind of wacky. If it's positive, think about from left to right. Right, we read from left to right. They were going up from left to right. They are going towards the positives. I call that a squiggly up. I like his wacky definition, though. So my very technical math terms, I would tell you that's a squiggly up. So the negative ones would be squiggly down, from left to right. Right, we read from left to right. It's going to still go, that one's going to go down. So those are my fancy terms for you. You got smiley face and sad face, squiggly up and squiggly down. I like stupid ways to remember things. Okay, so even and odd is based on your exponent. The plus and minus is based on the coefficient, the number in front. So we can kind of tell all of that just by looking at the equation. So describe the right and left hand behavior. So some teachers make you write on the left side, it's going up. On the right side, I don't care. Just draw me a sketch. I can see the left and right. That's all I need. So on this first one, it is odd, and the number in front is positive. So odd people don't have a normal smile, right? So it's not going to look like a normal smile. It would look like a squiggly one. It's a squiggly up because it's positive. So you could tell me the left side of that is going down, and the right side of that graph is going up. That's when it's asking for left and right. You can draw me a sketch like that, and I'm fine with it. Okay? All right, what about the next one? X to the fourth minus 2x cubed. That exponent is even. So you're not an odd smile. You're even, you're normal, whatever. And this is positive. So are you happy or are you sad? I'm happy. That one's a smiley face. Right? Both my ends are pointing up. Again, in between those ends, that graph could be doing some different things, and we'll talk about what it could possibly be doing in a minute. All right, the next one. Ooh. What's its degree? 3, which is odd. And the number in front, technically this would all get distributed, right? It's negative. So a negative odd. Squiggly down. Good. You're kind of odd. You don't have a normal smile. Kind of look like a stroke victim, I guess. Right? One side up, one side. That was not nice. All right, and that last one, it is even or odd? Even. And the number in front is negative. So even, so you got a normal smile or frown, but you're negative, so you are sad. It's a frowny face. Both of your ends will point down. Does that make sense? Kind of where I'm pulling that from? All right, then you guys try the next 4. So take a minute, go through all 4. Just kind of, you can just draw me a rough sketch of what you think it would look like. Smiley face, sad face, squiggly up, squiggly down. All right, who wants to come do the first one? Thanks, Grace. Guys will look up, I guess. If no one else will raise their hand, I guess I'll go. Sorry, you can show up how nice you look today. You guys all look so nice dressed for your interviews. That looks great. Pick on somebody for number 2. Okay, that first one, though, that was even and positive, so smiley face. Number 2. Very nice. That was odd, so it's one of your odd faces, and it is negative, so it's going downhill. All right, let's pick somebody for 3. Oh, he's even got fancy arrows. Nice. I love it. Odd and positive, so squiggly up. And the last one. You tell who likes to pick on each other. And Jace is very sad about coming to the board. Good. All right, questions on end behavior? All right. Last thing we need to talk about are turning points. Because like I said, we know what the ends are doing, but what's going on in between? I don't know. Maybe not always sure, right? So what's going to happen is the polynomial with a degree of n, so whatever that degree may be, it will have at most, because it doesn't have to have that many, n minus 1 turning points, or changes in direction. Okay, so if I look at this one, it changed direction once, twice, 3 times, 4 times. So if it changed directions 4 times, that means that was a 5th degree function, at least a 5th degree. Okay, right? Because it was a 5th degree, and then 5 minus 1 equals 4 turning points. Right? Kind of going off of what that said up there. So we can kind of think of it 2 different ways. If I know the degree, it's just n minus 1 for turning points. Right? So degree is equal to, it'd be n plus 1 turning points to get back to the degree. Or to find if I had turning points, depends on what I give you. It would be the degree minus 1. So depending if I give you the graph, and I can count how many points there are, add 1 to that, and that's what the degree is. If I tell you the degree, just subtract 1 from that, I can tell you how many turning points it would have. Could have. Right, because you guys graphed x to the 6th. X to the 6th could have how many turning points? 5. Right? 6 minus 1 is 5. But when you graph just x to the 6th, how many turning points did it actually only have? Look back at your graph. What did it look like? It just went, it looked like a parabola. It only had one turning point. So at most it would have is 5, but it could be less than that. It just depends on what else is in that equation. So if we look back here real quick, oops, there we go. So some of these, how many turning points would this one have? At most 2. So that'd be 2 turning points. This one would have at most 3 turning points. This one? That one? 5. All right, so that being said, let me flip it the other direction on you. If I have a graph, it looks like this. How many turning points? It has 1, 2, 3, 4, 5 turning points. So what degree would this be? That would be a 6th degree. Okay, so if I give you the graph, you have to add 1 to get to the degree because you know the turning points. But if I have to give you the degree, subtract 1 to find the turning points. Will it always have that many turning points? No, that's just the most it could have. So looking at this graph I just drew, do you know if even if you didn't count turning points, could you have told me that it was going to be an even exponent on that? Technically, it's a smiley face, right? It's a weird smiley face. But like, look at my ends. They're both up. You would have recognized it was even. Is this positive or negative? Positive. Your ends are pointing up. So it's got a lot of curves in it, but its end behavior is this, right? Both of its ends are pointing up. Ooh, that should not have a point there. Sorry. Something goofy like that. How many turning points does that have? It has 4 turning points. 4 turning points, right? So 1, 2, 3, 4. So what degree is it? It is a 5th degree, but you would use your fancy names, which is a quintic. Is that even or odd? It'd be odd. I have a test question every year, drives me nuts. People will have a graph like this, and I'll ask them, based on the graph, what the degree is, and then if it was even or odd. And I have people who are like, it's 5th degree. That's even. 5 is odd. Hello? Right, so that would be odd. And is it positive or negative? It's negative. Good. I can tie all that together. Just by looking at a graph, I can tell a lot of things. Or by looking at the equation, I can tell a lot of things about the graph. Just kind of some things. Do I know how high or how low all those lines went? No, I don't. I can't tell you that, but I can tell you how many curves it could have. All right, questions about all of this? All right, we're going to combine brain break with math today. Sorry, I know a lot of times we don't make them math related.